Hi everyone, this is MD Irfan and I'm a group member of group number 21 for Major Project 2, and this video is regarding Major Project 2 demonstration. Let me start with the explanation of the problem statement that we picked for our project. It is to train a machine learning model for traffic sign information with effective accuracy. And in my team, we are two people, Ashutosh Pandey and me, MD Irfan. Ashutosh Pandey is responsible for all the front end and back end tasks, and me, Mohammed Irfan, is responsible for machine learning, all the data selection and model selection and model training part. And we have built this particular project under the guidance of Professor Garima Mathur ma'am. And now let me explain you the idea behind our project and how we have approached a particular idea. So when it comes to a machine learning project, so first of all we need to take care about the data set that we are going to use to train our models. So we have researched about a number of data sets, and one of them was the German traffic sign data set that we have found an effective in the application. So it is a kind of authentic data set that we found in the Kaggle website, which is a kind of a famous site among the data scientists and machine learning engineers. So we have used that particular data to train our all the models. So the particular, if we I brief something about the model, so it contains over 50 million images, and has 43 classes, like 43 types of signs, traffic signs, that the particular data set contains. The next part comes is the preprocessing of the particular data. So as we have picked a particular data set from the Kaggle and the authentic site, so it we didn't find any ambiguity and noise on the data set. We just needed to resize our images to unify its size, and that's all we have done for the particular preprocessing. The next part comes is the models, like model selection. So here we have trained almost five models, like five models we have trained. Four one was the architecture that are pre-trained, and we have used transfer learning on them. Like those four were the VG16, VG19, efficient net, and the mobile net. We have found those performing well, but that was not according to our expectations. And we have found mobile net was performing very well, but it was on the accuracy chart. It has a fluctuating graph that was affecting our performance. So we then designed a custom model that contains the two convolutional layer, then followed by the max pool layer, then again two convolutional, and followed by the max pool layer, then that followed by the dense layer, and then the output layer, which has 43 nodes that distinguish that classify the images on the respective classes. So that is that particular model that we have used in our particular project. So if we talk about the machine learning training, so how it happens. So when we have selected our data and we have our models, so we feed that particular data on our model, and it trains itself, like using the feed forward propagation and the back propagation. So what happens on the forward propagation? So when we feed our data, so it does some calculations throughout the neural paths, and accumulate the particular result, and we then compare that particular predicted result with the actual result, and then apply the gradient descent method, and try to optimize particular data, and then find the difference, and then update all the weights during the back propagation. And then we do this particular process number of times until we didn't get the effective accuracy that we desired. So that is that all we did for the particular model and particular project, and we find our customer model working very effectively on the data set. So now let me demo the site that the web application that we have created to show the particular model that we have trained. So this is the front end page of our web application. The left part of which contains the information regarding data set, and it lists the all the data signs that all the traffic signs that we have in the particular data set. All 43 traffic signs are here. You may also see the labels of them. It is to verify whenever the particular person goes to and goes here and try to predict the particular image, like whether it is which class a particular sign belongs. So he can verify it from here also, that whether the particular thing is right or wrong. So like the prediction is right or wrong. So what we have here is in the right part is the drop box where we can drop our images, or we can browse it simply from the file path, and then we press submit, and the particular image gets sent to the server which is running on our WSL, and it will come here and it performs the it will feed that particular model into our it will feed that particular image into our model, and it will give us the prediction, and that prediction will respond it to the front end, and will just display that particular result on our front end. So let's see practically how it works. So let me go to the particular image dataset that where we have test images that we can use to test the particular platform that we have created. So here are some test images that we can see. So now take we can take one of them is like this is the general caution sign that we have here. Let's pick this one and drop and drag it here, and drag and drop it here. Now we have opened the particular image on our Dropbox. Now if when we will submit it, then the particular image will send to the backend, and it will feed the particular image on the on model, and we'll get the prediction and will display it here. So when I'll press the submit button, we'll get a prediction general caution. If you want to verify it from here, so you can verify from it here, like the particular sign is a general caution sign. And now we can clear it here, and we can send some another image, like it was the image that we have right now tested was quite clear, but if we have some blurry image like this one, so if we will paste here, so you can see this image is quite blurry, and when we submit it here, so we'll get the prediction as accurate as we were getting for the less blurry image. So we can verify it from here also that it's the roadwork sign. So this is our project that is giving us 100% efficiency and accuracy. Accuracy, like the model accuracy is not 100%; it is 99.05%. But the efficiency that we desired is up to mark. So we have finalized the particular model to use in application. We can use the particular model in various real-time applications. So that was our project, and thanks for viewing this image and following this demonstration.